Hello everyone, welcome to today's class. So for today we'll be looking at highest common factor or greatest common factor. Okay, but before we look at that, our first example will not be highest common factor. Our first example will be on the sum of all the common factors, playing with common factors. So let's see, example one, find the sum of all the common factors. Take note, sum of, our last class was find the sum of all the factors. But now we are looking at common factors of these two numbers. So what are we to do? Now when we have this, sorry, my writing, okay, solution. So when we are having this is what we do. We'll list out the factors of 24 and then we'll take the factors of 36. We'll take these factors. Now for 24, this I wouldn't stay to find all the factors, so we'll just list them out. We have 1, we have 2, we have 3, we have 4, 6, we have what else? 8, we have 12, we have 24, and then factors of 36, we have 1, 1, we have 2, we have 3, we have 4, we have 6, we have 9, we have 12, we have 18, and then we have 36. So these are the factors. So the next thing we are going to look at is that we are going to look at the common factors. Now, what do you mean by common factors? Common factors is the factors that we can find in the two numbers. So common factors will be equal to factors common to 1 to 24 and 36. So 1 is common. So we have 1. Remember, 1 is a factor of every number. Then 2 is common. So we have 2. 3 is common. We have 3. 4 is common. We have 4. 6 is common. And then 12 is common. So these are the common factors. Now, assuming our question was to find the HCF, of course, there are two methods. This is one of the methods. After finding the common factors, the highest of the common factors is 12. Is 12. But we are not really using this method to find the highest common factor. We use this method. I use this method when looking for common factors or maybe some of the common factors. So take note. So the sum will be equal to 1 plus 2 plus 3 plus 4 plus 6 plus 12. And that will give us 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 6, 12, or 10 plus 6, 16, and 16 plus and 16 plus 12 will give us 28. So our answer here is equal to 28. So that is the sum of all the common factors of 24 and 36. Okay, number two, find the HCF, that's the highest common factor of 18 and 24. Solution. What do we have? Now look at the principle I would like us to take. So we'll be doing it based on the division. So let's see, what and what do we have? We'll get our line here, then get our line here. Okay, so let's see, what do we have? We have 18, we have 18, and then we have 24. 18 and 24. So let's see, what can divide them? Now, in HCF, please take note, in HCF, we are only using the factors that can divide everything at the same time. So now we have 18 and 24. We are only looking at the factors that can divide 18 and 24 at the same time. The factor must divide the two numbers. So don't pick a factor that can divide one and leave one. No. You use factors in HCF, you use factors that can divide everything. Always do well to start with smaller numbers like 2 and 3, 2, 3, 5. Okay, let's see. Now, 18 is an even number, 24 is also an even number. So that means 2 can divide them. So 2 into 18, that will give us 9. 2 into 24, that will give us 12. Okay, so if you want to try 2, can 2 go? 2 in 2 cannot divide 9, but it can divide 12. So we are not looking for those kind of factors. We are looking for factors that can divide everything. So we go with what? I think 3 can divide 9, and 3 can also divide 12. 3 into 9 will be what? 3, and 3 into 12 will give us what? 4. Now this is where nothing can divide 3 and 4 except 1. We are not looking for 1 because 1 will not make any difference for us. So that is where we'll stop our division. So we'll stop there. So in HCF, you stop where nothing can divide everything at the same time. And then we can say that our HCF, is equal to 2. We are multiplying this and this. Our HCF is equals to 2 times 3, and that will be equal to 6. Our HCF equals to 2 times 3, which is equal to 6. Okay, example 3. Find the greatest number that can divide. When you just see greatest that can divide, that means we are looking at HCF. Find the greatest number that can divide 20, 30, and 45. 20, 30, and 45. Then solution. Okay, let's see what we are having. This will give us, um, let's try to draw our lines and see what to have. Okay. Have this. Let's make them big a bit. This, and then we'll have this. Okay, so let's see. This will be 20, this will be 30, and this will be 45. Now, what can divide 20, 30, and 45? These numbers end with 0 or 5, so 5 can divide. 5 into 20, that will give us 4. 5 into 30, 6. 5 into 45, that will give us 9. 9. So if we check, do we have anything that can divide 4, 6, and 9? I don't think so. So that means that is where we'll stop our division. So our HCF is equal to just 5. As our HCF equals to 5. And that's all we need. So that's the end of the example. So you have activities here. Find the HCF, um, find the sum. And take note, when there are three numbers, make sure you are looking for what can divide all of them at the same time. It shouldn't divide two and leave one. It should be able to divide everything at the same time. So activities, find the HCF, then the second one, find the sum of the common factors, of all the common factors. And then activity 3, the greatest number that can divide without, that's HCF. Thank you for watching this video. Please do well to like, to subscribe, and share to others. See you in our next class.